One is driving pulley, driven pulley, and the intermediate link that is called endless belt. Now, how the power is transmitted from driving pulley to driving pulley, the rotary motion transmitted to the belt in the form of linear motion. That linear motion again connected to driven wheel, driven pulley, right? Driven pulley, then the linear motion again converted into rotary motion in the driven pulley, right? This is the basic principle, working principle of flexible drive and rigid drive, right? Now, these are the things we discussed. Then how the power is transmitted means, in belt drive mechanism. Anyway, now already we discussed gear drive mechanism in belt due to coefficient of friction, the frictional force between the belt surface and pulley surface. That frictional force help us to transmit the power from one pulley to another pulley, means driving pulley, driven pulley. Okay. Now, the belt. What is the problem while using belt drive mechanism? It's a slip effect, because the belt is transmitted power from driven pulley to driving pulley to driven pulley, or vice versa. During that time, it will be possible to slip the belt because the belt is sitting on the plane surface. Plane surface. Then sometimes while the belt is going to be more wear and tear, then it is going to be a slip mechanism. Slip is going to be increased. This slip is one of the general problem in belt mechanism. And in gear mechanism, we are able to transmit the short distance power. In belt drive mechanism, we are able to transmit the power long distance up to 15 to 20 meters based on our applications, right? Now, the belt drive mechanism, it can be used to also the other another benefit, it will be easily absorb the shock and vibrations. That's what we discussed in the last class, right? And in belt drive mechanisms, now we are going to discuss V belt and flat belt. In broad, these two belts, cross section belts, V belt, flat belt, are very very important even in our automobile industries, right? Now, and another one more belt is round cross section belt. Round cross section belt. It's a rope belt. Okay. Now, yesterday we discussed these things, and difference between V belt and flat belt. What is the where is the more power transmission can be done? In V belt only. V belt, it can be done more power transmission, and flat belt we can transmit less power. But which one is more efficiency? Don't confuse. Efficiency, flat belt is more efficiency than V belt. Okay, V belt. But what kind of, how the coefficient of friction is generated in the V belt? Due to wedge action. Because in flat belt, sitting on the pulley in plane surface. In plane surface. Yeah, now just I see, show you this one. This is a plane surface, but our now, I mean, flat belt is sitting on the plane surface, but V belt is sitting on the, V belt is sitting on the trapezoidal. V belt is a cross section of the V belt is trapezoidal cross section, and the V belt groove, the pulley groove is also, it's a trapezoidal cross section, symmetric of the belt cross section. Then wedge action, the coefficient of friction is very high due to wedge action. Due to wedge action, the coefficient of friction is very high. Hence, it can be transmitted more power than flat belt here. Okay, that's what we discussed. The wedging action here. This is the wedging action. Okay, due to this wedging action, wedging action permits smaller arc of contact that increase the pulling effect, that increasing the pulling effect of the belt, then we can transmit more amount of power because of more coefficient of friction generated created in between the wedge surface, in the wedge surface and belt. wedge surface of the pulley and belt surface. Belt cross section surface is also in wedge shape. Now that's what we discussed yesterday, and very important things. I mean, what is the velocity ratio? What is the velocity ratio in? I mean, V belt and flat belt velocity ratio also we discussed, right? Which one is more velocity ratio? Which one is more velocity ratio? Please tell me that. Anyone? Velocity ratio. Which one is V belt and flat belt and rope? Which one is more velocity ratio? Chain drive. Okay, guys, someone open mouth. Which one is more velocity ratio? Yeah, tell me. Which one is more velocity ratio? Okay, what is the flat belt velocity ratio? Flat belt velocity ratio. Yeah, tell me, pa. Hello. Some value, tell me, man. Velocity ratio. Yesterday, I wrote in the slide also. What is the velocity ratio of flat belt? Velocity. Eh? Yeah, please, someone. Hello.
Flat belt 4:1 and V belt 7:1, sir.
Yes, thank you, pa. Thank you. Flat belt 4:1, V belt is 7:1, and the chain drive is, I mean, 50, or some books they mentioned 15. I mean, Bandari book, I referred other book, they mentioned 17:1. Okay, chain drive. Okay, now we move to this further. This is already we discussed. Now this is nothing but we built cross section. Now this is the wedge we built dimensions. This is standard dimensions how it is available. And now the we built construction. This is outer layer is a band ply. This is adhesion gum in the outer layer. This is a tensile cord. We are going to discuss later. Okay, why it's required. This is a rubber cord. This is under cord of rubber. This one. Okay, this is the now this is the different types of belt. This is the classical V belt dimension. This is a wedge V belt dimension. Okay, now I come to this V belt power transmission in different applications. Now for your in our fitness equipment, we are using up to 5 kW V belt. We are using V belt in fitness centers for maximum power transmission in 5 kW. And we are using in gardening equipment 10 kilowatt. We are using there also we are using V belt. I mean refrigeration and ventilation machines we are using V belt for transmitting the power 15 kilowatt. Okay. Now see here then transporting the people you might have been seen in railway station, right? Here we are using 50 kilowatt, 50 kilowatt. Okay, we are using V belt for power transmission, and timber industry 90 kilowatt, and aerospace industry 100 kilowatt. Now these are the paper industry 200 kilowatt we are using V belt, and then see here mines and quarries here we are using 600 kilowatt power transmission. Using V belt for 600 kilowatt power transmission. Okay. Now I come to this. The earlier class, in the last class, we discussed advantages of V belt, advantages of flat belt. Okay, and disadvantages of V belt and flat belt we discussed earlier in the last class. Now point by point I have given you, given the slides. Please go ahead. We already discussed. Okay. Now flat belt drive and V belt drive comparison also, the enough points we already discussed. I mean, this is a rectangular cross section. This is a trapezoidal cross section, right? This simple design, the construction of V-belt is complicated design, and also, I mean, little maintenance, complicated. I mean, maintenance also complicated, and this flat belt drive, it can be easily fabricated. It can be easily assembled and disassembled from the pulleys. Okay, I mean, this is the friction engagement of the outer pulley surface. Here, a friction engagement, lateral wedge surface in the side of the trapezoidal cross section of the groove, groove in the pulley. Okay, the slip, I mean, this point, slip may occur, the slip is, occur in the flat belt and V belt. Slip is negligible. We are not saying slip not occur. Slip is negligible. Okay, and due to wedging action between the belt and V groove, slip is negligible. That's what. So these are the points we already discussed. And the flat belt can be used for long distance power transmission. V belt can be used for small distance, and flat belt can be used for, I mean, crossed belt drive application for transmitting the power from opposite direction from driving pulley to driven pulley. But V belt is difficult. We can't say we cannot use, but very difficult to use cross applications. I mean, this is a flat belt low velocity ratio. V belt is high velocity. Just now we have been discussed. Your friend told that 7.1, 7 is to 1 velocity ratio for V belt, and flat belt 4 is to 1. So obviously V belt is high velocity ratio. Okay, this is the things we discussed. Now, I mean, vertical direction we can't use V belt, but sorry, flat belt. V belt it can be used hopefully. Okay. Now I come to this. Now, I mean, belt construction. So belt construction. Now, before going to enter into the belt construction, we should understand the belt material properties. Belt material properties is very important before entering into the belt construction. Now, that belt material should have should have a high coefficient of friction. Obviously, because the power transmission depends on coefficient of friction between the belt surface and pulley surface. And the belt material should have high tensile strength for withstand the belt tensions. Okay, why we are considering tensile strength? Yeah, someone tell that. Why we are considering tensile strength? Why don't we consider crescent strength? I mean, sigma C, compressive strength. Especially why we are considering tensile strength. Hmm? Yeah, please, someone. If you are not, if you don't know, please ask me. I tell you that. But please try to say relevant answer at least. Why we are considering belt? I mean, tensile strength.
Because the belt might undergo tension during the power transmission, no, sir?
Exactly. But another way, the belt here, this both pulleys are in same rotation. Hence, obviously going to be in tensile behavior in the tight side. Slack side is very small. I mean, the tension is very less. Slack side is almost, I mean, as compared to tight side, this side is now tight side. We, yeah, thank you, but correct. You are correct. Now, another reason I am telling this side the belt is now the pulley is driving pulley is rotating like this. This guy. Okay, anyway. Now the driving pulley and driven pulley rotating same direction. This top side going to be acting as a tight side. Now bottom side BP1, bottom side acting as a slack side. Right now during that time, I mean both are in same direction. Obviously, is going to be subjected into tensile behavior. But slack side always less load. Hence, we are mostly concentrating tensile strength only. Okay, the belt material should have high wear strength. The belt material should have high wear strength. The belt material have high flexibility and low rigidity in bending in order to avoid the bending stress. We will see uh, what is the bending, how the bending stresses impact our belt design. We will see later. Okay, these are the things you are very simple, you can easily understand. Belt material should have high coefficient friction, high tensile strength, high wear resistance, flexibility and low rigidity. Then only it can be easily transmitted the motion from linear motion to rotary motion. Okay, now belt, mostly belts are made by leather, canvas, and rubber. Leather, canvas, rubber, and rubberized fabric. These are the material we are using, and also synthetic material we are using for preparing the belt. There are two types of belt. One is leather belt, fabric rubber belt. Only leather belt. Other one is fabric plus rubber belt. Fabric plus rubber belt. One by one we see that. The main advantage of leather belt is high coefficient. Now we are talking about leather belt. Leather belt is high coefficient of friction. High coefficient of friction. Consequently high power transmission capacity. Leather belt. Okay, and we will see fabric rubber belt in later. Okay, now see, this is there is a specific term we are using, ply. Ply here, using the ply in practically we are increasing the thickness of the belt by increasing the layer of leather or layer of fabric. Hence that increase the thickness by adding the layers, that is called plies. But adding the layers, that is called plies, for increasing the thickness of the belt. Okay, now see here, this is the 4-ply leather belt. 4-ply leather belt, you can see here. In this 4-ply leather belt, the ply 1, ply layer 1, layer 2, see here, layer 1, layer 2, layer 3, layer 4. Okay, this is 4-ply leather belt. Now, and another thing, the belts are specified according to the number of layers. We are saying that plies, number of layers are plies, right? There is single ply, double ply, double ply, or triple ply, or 4-ply. But the power rating of belt, as in standard way, we are indicating that belt, high speed belt is 1.118 kilowatt per ply per mm. Width of the belt, it's nothing but 0.118 per ply. For each ply, how much power is able to transmit it. Like that we are mentioning. And per mm width of the belt. Per mm width of the belt. Now here, now the belt is now along the cross section we are seeing now. This is the belt in 3-dimensional view. Now what I am saying, each belt, each layer, we are telling that 0.0118 kilowatt per ply, this ply for example, and per mm width along the thickness. And in future, when we are going to discuss the power transmission capacity of the belt, we are going to consider this way of indication, this way of notation. Power transmission capacity per ply per mm width of the belt. Per mm width of the belt. Okay. Sorry, per mm width of the belt we are going to discuss in the later. Now I come to the fabric rubber. Fabric rubber belts are made from several layers of canvas, okay, or cotton tag impregnated with rubber. See here, this is the okay fabric rubber belt. Now the fabric. Now in this fabric rubber belt, the fabric material is a major portion of the load transmission. The fabric component, fabric material in this belt is absorbing the load carrying capacity. Okay, and rubber is protects the fabric against the damage. Now, see here, this is now, I mean, this is fabric material. In between the fabric material, we are using this. In between fabric, we are using the rubber. Okay, fabric rubber. Now, the fabric is this the fabric rubber belts made of several layers of canvas and cotton tag impregnated with the rubber. Okay, rubber. Here the fabric transmit the power. The fabric is the main component to transmit the power. The rubber is a protect the fabric against the damage and increase the coefficient of friction. Okay, anyway, this is simple theory only. You can get it. Now, this again the fabric rubber belt classified into three types. The first one is whatever we discussed now. Now the first one is 1 minute. The first one is layer by layer edge belt. Layer by layer folded edge belt. Layer by layer folded edge belt. This one. Layer by layer folded edge belt. The second one is, second one is, I mean, I think, sorry, I think I did a mistake. Raw edge belt. Sorry, this is raw edge belt. This is raw edge belt. This is raw edge belt. This is layer folded edge belt. This is spherically warped edge belt. Spherically warped edge belt. Because in the next page I didn't put the figure. Yeah, sorry, I already put the figure. I thought it's not this figure not there like that. I thought that's what I have written there. Anyway, now we see here the advantages of fabric belt. Then we come to this each one. Advantage of fabric belt is high load carrying capacity. It's a long service life. It can operate high speeds. Up to 300 meter per second velocity. What is the disadvantages? I mean, it cannot operate a small diameter pulleys. It can be used in bigger diameter pulleys. And this is subjected to destruction in an environmental mineral oil, gasoline, alkalines. This is chemically it will be react. That is the disadvantage. And then there are three types. One is raw edge belt. Now this is a raw edge belt. The first one is raw edge belt. Now it consists of plies of fabric and cut along the width of the belt. This is now along the width of the belt. Cut along the width of the belt. There are the layers rubber between the plies of the fabric. Whatever I have been told in the earlier, here the rubber in between the plies. Okay. The edges of fabric are protected by the waterproof compound. The edges of the fabric protected by the waterproof compound. Therefore, the widely used for high-speed application. Okay, very simple. And the second one is layer by layer edge belt. It consists of center ply. See here the center ply warped around the rectangular plies. The center ply is warped around the rectangular plies. See here the center ply warp. The center ply. This is the center ply. warped around the rectangular plies, each rectangular plies. So again, now in this case, we are using, I mean, the rubber may be fabricated or may not be fabricated with the fabric. Okay, in this, I mean, in this layer by layer folded edge belt. But now the last belt is, I mean, here it's based on the orientation of the fabric, we are defining the belt types. Okay, this is way oriented, the design is oriented like this, we are saying this. I mean, here this way the ply is oriented like this, the central ply, around the central ply rectangular plies are oriented. This is like layer by layer folded edge belt. The last one is spherically warped edge belt. Here there is a single piece of fabric. This is made with a single piece of fabric. See here, no cut, single piece of fabric wound in the form of spherical nature, spherical design. Hence, this is spherically warped edge belt. Here, not required rubber. Here we are not using rubber in the belt. Okay, but in raw edge belt we need rubber. Rubber going to be, I mean, the rubber will be fabricated with the raw edge belt. In layer by layer edge belt, rubber may be rubber is may be fabricated with the fabric material or it may not be. But in spherically edge warped folded edge belt, rubber, I mean, may not be, rubber is not required. Here rubber is not required. Rubber layers not required in this belt. Okay, then the another, now this is the way we are making the belt. Okay, now I come to this flat belts produced from the long bands. Now we are going to discuss about one more thing I think missed out. Now we discussed about the belt, but how to connect the belt? How, I mean, see here, belt is thickness, we are having standard dimension. Belt tension, how much power transmission capacity, that also we are going to have a standard values. But here the power transmission capacity also standard value, but the power transmission distance may not be standard. Person to person it may changes. Hence, most of the belt company, what they are doing, especially in flat belt, they are making in the straight belt and they are wound on the coil, stored and wound on the coil. Then suppose the person X is coming and asking, give me a 2 meter length of the belt, they will give in the form of straight belt. Then based on this, based on the person X, he has to he has to connect the two end of the belt to for the power transmission application. Hence, we are using different joint mechanism for connecting the two ends of the flat and straight belt. Now, this is the, that's what we are going to discuss, how to join two ends. That's what our intention to discuss. This is the belt now. The belt is initially straight and flat belt. The belt was wound in the coil. Now after purchasing person X, I would like to make the endless belt. Then this end 1 and end 2 to be connected in appropriate manner for transmitting the power. Then based on that connection, we are going to classify different connection. One is cemented joint, second one is lost joint, third one is joint with metal fastener. We will see that how we are connecting. Now the first one is cemented joint. The cemented joint, now, I mean, this end of the belt going to be connected along the cross section, along the width, this width of the belt, right? This is going to be connected like this manner. Okay, that's what. The leather belt cemented with a tapered joint of 20 to 25 mm. 1 minute, please. Take this side. Disturbing me, this one. Okay, 20 to 25 mm thickness. Now we are telling this only. This a tapered joint length might be 20 to 25 times thickness. The length, the tapered length is 20 to 25 mm, 25 times the thickness of the belt. Okay, these these two joints are cemented joint. Cemented joint. I mean here the second one is now in the second, this is the multi-layered belt. Multi-layered belt are cemented in the form of stepped joint. The first one is single layer. The first one is single layer. Okay, the second one is multi-layered belt. Multi-layered belt, how to make the connection both end one and two. Now this is a 20 to 25 mm thick, 25 mm length we should follow while using this tapered lap joint. Now the second one is when the belt is multi-layered thickness, multiply belts, then cemented. I mean, while the joints going to be like this. This is like nothing but cemented joints. I mean, this is nothing but a stepped joint. Stepped joint, we have to use this kind of joint when our belt is multiply belts. Okay, I mean, what is the efficiency strength 80 to 85 percentage of the strength of the belt. I mean, this is, I mean, we already discussed, no, in the last semester, with the whole the plate strength, without the whole the plate strength. Similarly, this is when the belt is a plain belt, what is the strength? The strength will be high. When we connect, we are destroying this and we are connecting. It's not originality of the belt, even though the strength cannot be obtained originality of the belt. Hence, now 80 to 80 percentage of the belt strength. When you make this connection, then as compared to plain belt, that plain belt strength after joints, after this join, after like these two joints, the belt strength corresponding this joining place is going to be 80 to 80 percentage, 85 percentage of the strength of the belt. Then the last belt is nothing but now cat cut with the rawhide strips. Rawhide. This is nothing but a stitching the belt. Okay. Now what is the strength here? This is the 50 percentage of the belt strength. 50 percentage of the strength of the belt. Now the last one is simply they're folding and using metal fastener and using the keys. You might have been seen. Now the belt is like that. They're using some pins. Now here they're using small pins. You might have been seen in somewhere in practically in people are using, I mean, pumping the water from well. They're using engine. The engine is connected to pump, right? That the engine is connected to the pump through the belt. Then many people are using this kind of joints. This is called hinged, also called hinged joints. Here we are, this is called hinged joints. Here we are using metal fasteners. This is like L clamp. The L clamp again it will be used with some horizontal link, and the link will be again it will be locked using some kind of pins. Then the power transmission going to be happened from engine to pump. Okay, so this for lifting the rising the water from the well. Okay, here this is metal fasteners, but this is a less strength, 25 percentage of the strength of the belt. Now come to the V belt construction. Now this is the baluster and cords with the rubber reinforcement. The cross section of the belt is see here. This is the outer cover of the belt. This is the load carrying cords. Load carrying cords. These load carrying cords may be this baluster fabric, or this sometimes you can see the belt inside is a high, even metal wires also people are using. Okay, this is the rubber material. This is rubber material. This is a cover, outer cover of the material. Okay, the central load carrying central load carrying layers of polyester cords or polyester fabric which are located in the horizontal lines. This is the major load carrying capacity. This is the portion major load carrying capacity of the portion of the belt. While tensile load when the belt is transmitting the power from driving pulley to driven pulley. Now, this is, I mean, now with this load carrying cords or polyester fabric material or this may be steel wires. All are located at the center of the gravity of the belt cross section. I mean, center of the gravity of the belt cross section. Because now this trapezoidal cross section. Hence, the polyester fabric material or cords are not located exactly center of the trapezoidal cross section. This is located based on the center of gravity of the belt cross section. Suppose, for example, for our understanding, the belt cross section is square, then exactly sitting at the center of the cross section of the belt. The cords are sitting in the exactly center of the cross section of the belt. Now this is a trapezoidal cross section, hence sitting here. Based on the center of gravity, hence sitting here. Because I come to back because because see here the later you should not confuse. That's what I'm telling here. Based on see here, these are the things. These are the things. The line that this line this row here sitting each cards are sitting based on the center of gravity of the cross section of the trapezoidal cross section of the belt. Okay, just a minute. Okay. Now I am going to ask you a small question. Why we are keeping polyester cords at the center of the belt cross section? Yeah, guys, someone making noise. Please switch on your TV or please mute. Hello. Hey, it's a disturbing to us. Yeah, Kalyan, can you put a message? Hello. Okay. Now I ask the question to you. Why we are keeping the polyester cords at the center of the gravity of the belt cross section? Do you have any other reason? I already told you load carrying capacity is more. But in general, I'm asking one question. Why we are keeping the polyester cords, polyester, polyester cords or load carrying cords at the center of the gravity of the cross section of the belt? Why? Hello? Yeah, please reflect. We have to go. We have law. Yeah, this is a big chapter. Why we are keeping the load carrying cords at the center of the gravity of the belt cross section? Any other reason? Please tell me. I tell you, I give you a clue. Now this is the driving pulley. This is a driven pulley. Sorry. Yeah, tell me, please. Someone tell that to us. Another reason. Now power is here. rotary motion converted into linear motion, again linear motion converted to rotary motion. Now why these load carrying cards are at the center of gravity of the belt cross section? Why we can't keep here? Yeah, please someone open mouth, please. Otherwise I can't move. Tell me, pa, please. Now the linear motion going to be this converted into rotary motion. During that time, what is happening? The belt is now, while what is happening in this corner? The belt, in the belt. Yeah, Amarnath, Kalyan.
Deformation.
Yeah, okay. Again, yeah, think about that. Think. Another, yeah, another reason. What is happening here in this, especially in this region where I am highlighting? Tell me, pa. Hello. Okay, I give you a clue. Is it bending or not bending? The belt is now the linear motion going to be bending or not bending in this region now?
Bending, sir.
Yeah, now you tell me. You might have been seen not only polyester fabric material they are used. Sometimes there we are using even steel wires also. But mostly the designer suggested that a polyester cards or wires, whatever you are using in this V belt, but they are preferring, mostly they are preferring at the center of the gravity of the belt cross section. Okay. Now I have
Sir,
given you clue the bending. Yeah, tell me, pa.
to have no bending stress in the cords.
Yeah, exactly. Thank you. Very important. Thank you. Now the bending says at the this neutral layer, right? Where is the neutral layer? Neutral layer always sitting at the center of gravity of the cross section. Hence, these cords, these steel wires, going to have zero bending stress. Then it can, because this is a steel wires, it's suppose subjected to bending stress, what will happen? The the belt structure going to be, I mean, distorted, warped, right? Hence we would like to avoid. Then while going this, while transmitting the power, whenever the belt is crossing the corner region, immediately it will come to the plane safe. Before plane, bending before plane, bending after plane, then easily it will come to their original shape. So here the bending is going to be 0. Only we are allowing tensile load in these cards. That's what we are always, mostly we are preferring to design our load carrying cards at the center of gravity of the belt cross section. Okay. Now I come to the length of the belt. Okay, now the length of the belt, there are two types of belt, you know, right? One is open and crossed belt. Now I'm not going to concentrate more and more about this. Okay, now see here in the, just with three, see this, the difference between the open belt and cross belt. You know, open belt is, I mean, when we are using open belt, the open belt in the driven and driving pulley, it will be rotate same direction, right? The belt proceeds with the top of the, from top of the one pulley to the top of the another without the crossing. That is the open belt. That's what we, anyway. This is open belt. This is not cross to each other, but in cross belt, cross to each other, right? Now here this is the directions are both direction. The driving pulley and driven pulley both the directions are same. Here the driving pulley and driven pulley both the directions are different, opposite. Okay, now we are going to discuss about the length of the belt. Okay, now any other things I'm missing here? Now, I mean the angle of warp. See here, I mean when angle of warp, when the driving pulley, okay, pulley 1, I'm considering pulley 1, pulley 2, both are in same size. Your angle of warping going to be 180 degree. Suppose pulley is 2, this is very important concept. Pulley, it says one pulley is smaller pulley, another pulley is bigger pulley. Then now what is happening? What is happening? Now which one is now this one is now this is angle of contact. Now in this case both pulleys are same. The belt contact angle on the pulley, both pulleys are same. When these two pulleys diameter same, d1 now this is d1 d2, this is d1 is greater than d2. In this case here angle of contact of the belt, angle of contact or angle of warping going to be, I mean alpha greater than 180 degree, but in this case alpha is less than 180 degree, less than 180 degree. Now come to the cross belt, but cross belt always, even both the pulleys are same diameter, d1 is equal to d2, d1 is greater than d2, both the case that angle of warping always greater than 180 degree. This kind of questions you may expect any competitive exam. Okay, even our objective. Okay, this is very important. Now we would like to find out the length of the belt. So as I told you that in companies, most of the manufacturing company, flat belt manufacturing company, they are making long belt and they are wound it on the cylinder wheel, right? And we would like to find out the length of the belt based on our requirement of power transmission distance between two pulleys, right? Now we are going to discuss that now. Okay. Now see here, and one more thing now, I mean, in open belt, when the center distance is more, then the belt will be vibrate. Obviously, I think, yeah, this is, I erased it. Okay, now what happened? When the open belt drive, for example, open belt drive, the center distance is more. What will happen? It will be vibrates. The vibrates perpendicular to the direction of motion. When the belt is vibrates, perpendicular to the direction of motion. Perpendicular to the direction of motion. Vibrations are going to be perpendicular to the direction of motion. It's not parallel to the direction of motion. You may expect this type of objective type questions. When the center distance is small, the belt slip is going to be increased. Slip is increased. Now in cross belt drive, see here. Now which one is more coefficient of friction? Which one is created more frictional resistance? V belt or open belt? I mean, sorry, cross belt or open belt? Cross belt only. Because see here, the contact region on the down on the fly on the pulley, the surface of contact is more in cross belt as compared to V belt, I mean open belt. Hence, this is more power transmission can be done in V cross belt as compared to flat belt in open belt. Open belt can be done small power transmission can capacity, but in cross belt we can do more power transmission capacity. But what is another problem in cross belt? Cross belt, when the, I mean the distance is small, is the belt slip increases, but the both factors limit the open belt drive. Anyway, cross belt drive do not have that limitations, but in this is wear and tear is more in cross belt drive that may reduce the life of the belt. Now see here, I mean not only wear and tear, where the belts are crossing, I mean tight side and slack side are crossing, I mean crossing, that place also the belt is going to have wear and tear. Because possibilities of touching to each other, hence that place also the belt is getting damaged. Okay, these are the negative things. Now we move to the belt length of the belt. Now anyway, these are the terminology we should know, because we are going to solve the problem later. We are going to use this same terminology. This is warp angle for small pulley. I mean, this is a warp angle for bigger pulley. Diameter of the bigger pulley D, capital D. Smaller diameter of the pulley, small d. And center distance. The center distance, the smaller diameter of pulley. This is a bigger diameter of pulley. Now we would like to find out the length of the belt. This is open belt. Now see here, this is line OG. This is the line OG. Draw a parallel line. This is the line, outer of the line. From this point, draw a parallel line to our bigger pulley side. Draw a parallel line to bigger side, or else you can mean another way. I mean, some books they're telling that draw a perpendicular line from the bigger pulley. Some books they're telling that you can draw a parallel line to our belt. Draw a parallel line belt from the starting pulley here. From the starting pulley here, obviously the line is going to meet in perpendicular to this radius of this belt, bigger side belt, bigger side pulley. Sorry. Now, or else you can draw a perpendicular line where the line is making perpendicular. That line must meet through this point. Then that concept now we are going to use to find out our length of the belt. Okay, so now I mean, once I have drawn the perpendicular parallel lines. Now OB is equal to GC here. Now OB. Now this is OB here. Okay. I don't like to spend more time because you may know some of the concept here. Now I move fast manner. Now see here, OB here, where it is OB, this O and B, this is the radius of the smaller pulley, right? OB is equal to OC, smaller pulley. Now what is sine beta? This is the, I mean, opposite side. This is the adjacent side. This is the hypotenuse side, right? From this, sine beta is equal to sine beta. Sine beta is equal to O1G. Sorry, I did a small mistake. This is the hypotenuse side. Sorry, I think adjacent side. Sorry. This is O1. This is O1 is hypotenuse side. O1G is opposite side. Then GO is GO or OG is adjacent side. Okay. Now this is the sine beta. Now this is angle beta. Then similarly this is also angle beta. Now sine beta is equal to, now this is angle. We know these dimensions. I mean OC minus O1C minus GC. O1C minus GC. GC is nothing but our smaller pulley radius. Hence O1C minus OB. Then D by 2 minus D by 2. Then D, capital D minus, I complete just 2 minutes. Okay, capital D minus small d divided by 2c, because this distance is small, capital C we consider. Okay, then this is sine beta is equal to D minus capital D minus small d divided by 2c. Then alpha s, as I told you that this open pulley smaller diameter, then 180 degree minus 2 beta, because our starting point of the belt is here. Okay, 180 minus 2 beta, and bigger side, bigger pulley is 180 plus 2 beta, because 180 plus beta, 2 beta. Simple concept. You take small one coin, you take bigger coin, then connect it to one thread. Then smaller coin side, the contact of the thread is less than 180 degree. So I mean bigger coin side, the contact of thread is more than 180 degree. Hence this side is a beta, this side also beta. Then 180 plus 2 beta, this region. 180 plus 2 beta. So now alpha is nothing but 180 minus 2 beta. I mean, now beta we know already. The sine beta is equal to D minus capital D minus small d divided by 2c. Substitute here. Then alpha B, bigger side, warp angle or contact angle of belt is 180 plus 2 sine inverse or d minus 2 d minus small d divided by 2c. Substitute this value here. Okay, this is now come to here. I mean the length of the belt now we know, right? This is the first I am starting from here. FAB, FAB. This length arc of the belt. Then again, I mean BC, BC, right? Then again arc of belt in bigger side pulley CDE. Then again EF. Okay, this is the concept now. Now arc of the belt here. What is arc here? D by 2 into angle. It will give the this particular portion length of the belt into angle alpha s because smaller side pulley. Then OG we know what is OG. I mean OG is nothing but our BC. BC is nothing but OG. Yeah, OG, BC both are parallel and OG plus D by 2 into arc of contact. Yeah, this is arc of CDE. Now see, I mean here arc D by 2. This is a bigger pulley side radius D by 2, right? D by 2 into arc of contact 180 degree greater than 180 degree. That is alpha B, whatever we discussed earlier. Plus OG. That's OG is nothing but E. I mean this length. EF. EF is nothing but OG. OG. Then simplify this. Now earlier we know this is a D by 2. I mean pi minus 2 beta. This is 180 less than 180 degree alpha s. Then pi minus 2 beta into C into cos beta. C into cos beta is nothing but now this OG, this is now adjacent side. Take this right angle triangle, find out OG. OG is nothing but C into cos beta because C is nothing but this distance O1 distance. I mean hypotenuse dimension is C, then C into cos beta. Then come to bigger side pulling D by 2. This is the greater than 180 degree. Then pi plus 2 beta. Pi plus 2 beta. Then again this side is based on this rectangle triangle here again C into cos beta. Now again simplify this. Now L plus simplify this equation. Finally L is equal to pi into D plus D by 2 plus beta into D minus D plus 2C into cos beta. Now substitute our beta value. Already we know beta is equal to, I mean in smaller side, the smaller pulley side, beta sine beta is equal to D minus capital D minus small d divided by 2C. Then cos beta we don't know, but from this formula we can get it. What is cos beta? Use this for relation. I complete within 2 minutes. Cos 2 theta sine 2 theta relation. What is cos 2 theta relation? Now cos 2 theta is equal to 1 minus 2 sine square theta, right? Now I mean beta is a small value, sine beta is very small value, hence we are considering beta. Then 1 minus 2 sine square theta, sine 2 sine square theta is nothing but this is a 2 into beta squared by 2, beta squared by 2. Already beta by 2 is there. Now here this is sine 2 sine beta, okay, but sine 2 theta is equal to this, then beta squared by 2, then beta squared by 4, then finally it will come beta by 2. 1 minus beta squared by 2 it will come. Then substitute this 1 minus beta squared by 2, then substitute wherever this is the value, substitute in our earlier equation. 1 minus beta is nothing but d minus 2d by 2c, substitute here. Then now we know this, substitute our equation here, substitute in our equation. Finally we are getting this open belt length is like this. Now sorry, this is a final equation. Length of the open belt 2c plus pi into d plus d by 2 in plus d minus d by 4c. Okay, I mean d minus d whole square divided by 4c. Very simple. It's not a difficult one. Anyway, I complete last one. This is the cross belt. Now same concept, but what is the difference here? Here, this is the only this one. See here. Now see here this one. Now 2c plus pi into capital D plus small d divided by 2 plus capital D minus small d whole square divided by 4c. Now because one side belt, contact angle is less than 180 degree, bigger side pulley greater than 180 degree, hence where the greater than 180 degree comes, that's based on that we have defined that d pi into d plus d by 2. But where that belt is smaller pulley side angle, contact angle is less than 180 degree, hence d minus d into whole squared by 4c is playing role. But when the both sides are contact angle is greater than 180 degree, then this both the terminology going to be d plus d by 2. Here also d plus d whole squared by 4c. That's all. Remaining concept is same only. See here, the smaller side angle of contact of the belt warp angle is 180 plus 2 beta in smaller side, and bigger side also 180 plus 2 beta. Then finally we are getting alpha s is equal to alpha b is equal to 180 plus 2 sine inverse of d plus d by 2c. This is the belt length when we are going for purchasing these. I mean, we want to transmit the power in opposite direction from driving pulley to driven pulley, then we have to go for cross belt design. Then cross belt design, we have to find out the length of the belt. Then we can buy it length of the belt in straight manner. Then we can connect it. We already discussed how to connect the two ends of the belt and the straight man. When the belt in the raw belt, we have to connect it to two ends in proper manner. We already discussed there are three types of joints we use to connect the belt for our applications. This length of the belt. In the next class we are going to discuss the analysis of the belt tension and corresponding problems. Yeah, please, if you have any doubt, please go ahead. Hello guys, please go ahead if you have any doubt.
No.
Okay, I take attendance and then you leave the class. Anyway, you are going to come to the campus. They may consider the attendance. If you are not attending the class, it will be problem.